So there's a revolution going on in medicine that we want personalised healthcare. We want to understand our own bodies, the individual nature of those. And for that we need sensors, but not just on the outside, we need sensors on the inside. And we've not been very good at making those. So nanoscience and nanotechnology is driving towards making new sorts of devices that will really revolutionise medicine. This is the idea of personalised medicine as a whole. How do we actually know how we're working as a human? When you go to a doctor, they always ask you how you're feeling, and part of the reason is they have no machine which can measure how you're feeling. So it's about how do we create technologies that actually can read that out and do something much more profound, actually watch how you're living and then start to warn when maybe something is going wrong. Now, on the very, very future scale, what we actually really want to do is to put nanomachines inside our bodies. We want them to go and scavenge away and repair parts which are broken, remove clots, and all at the moment this is rather large-scale interventions. So surgeons have to push something in your body. What we'd really like to do is to use what the body does. And so nanotechnology is learning how to build these sort of nanomachines.
Since the 1800s, scientists have developed vaccines and medicines by growing cells in glass petri dishes. It was instrumental in advancing biological science for the past few centuries. In recent years, with the advent of 3D printing, the 2D petri dish has now been upgraded to another dimension. A revolution has started to develop lab-grown organs for transplants. Researchers at Israel's Tel Aviv University have just successfully 3D printed a heart made from real human cells. Previously, this was only achieved with non-organic materials such as silicon.
Beyond incredible potential breakthrough in making organs in a lab.
Israeli researchers have printed a 3D heart complete with muscle and blood vessels.
He explained that the cells that made the heart came from a donor's fat tissue, which are then transformed into embryonic stem cells and then differentiated into the various cell types in the heart.
The heart is small, only about the size of a rabbit's heart. However, researchers were able to create chambers and veins which nobody had previously achieved before. The researchers envision creating 3D printed hearts suitable for human transplants and also patches which can regenerate defective tissue.
Imagine having the ability to zoom in on objects, take photographs, or record videos without an external device and literally in the blink of an eye. Imagine a lens that gives you better than 20/20 vision well into your old age, or being able to get the news in front of you anywhere at any time. That is exactly what scientists are trying to achieve with smart contact lenses. Researchers from the University of California, San Diego developed robotic contact lenses that can zoom in up to 32%. All you need to do is blink twice with the contacts in your eyes. Incredibly, the lens doesn't require batteries because it uses the electricity produced by specific movements in the eye. To make these smart contact lenses, researchers use micro versions of existing technologies. These lenses are designed to harvest energy. They're exposed to the mechanical movement and kinetic energy of blinking, which is then converted into electrical power. Smart contact lens technology could accelerate vision beyond natural human capabilities.